Hello and good morning to the audiences joining from Middle East, and good afternoon to India and Southeast Asia audiences. I am Sanjeev Verma. I am a Senior Practice Manager for Security Testing Services at Paladion. This webinar is intended to help our customers and other small, mid, and enterprise level organizations in understanding, identifying, and mitigating the ShellShock vulnerability. During this webinar, I will introduce you to a few concepts and terminologies that will be helpful during the session to understand the ShellShock vulnerability in a much better way. Then I will talk about the ShellShock vulnerability, the different attack vectors over HTTP, SSH, DHCP, and whatever residual attack vectors that might be present. We would also talk about the impacts of the ShellShock vulnerability if exploited. Later, I'll explain a phase-wise mitigation plan with the detailed steps of identification and remediation. Towards the end, I will share a consolidated list of 20-odd popular platforms, and we'll see whether those platforms are affected by the ShellShock vulnerability or not, and what is the status of patches that the vendor has released. And finally, we'll have a look at a couple of the security devices like WAF and IDS and IPS, and see if there's any signature update that has come in from the vendor side. So Bash shell is an acronym of Born Again Shell, which is a command interpreter. It takes the user enter value as a command and executes it and shows the result back to the user. It was developed in 1989 and is distributed, one of the most widely distributed command interpreters with Unix, Linux, and other Linux-based systems, including Mac OS. The environment variables are memory objects, dynamic objects that can be accessed by a process or program. The value of a memory environment variable can affect the behavior of a process or program and eventually the end results of a program or a process. What is ShellShock? Basically, ShellShock is a command injection vulnerability. People also refer it as a code injection vulnerability in the Bash shell, which is caused due to the improper handling of the propagated environment variables. By propagated environment variable, we mean parameters passed on by the parent process or program to the Bash program. The environment variable can contain, is ideally expected to accept a single string as a value or a method definition. Now, when an attacker sends a payload, malicious payload, as shown on the screen here, which includes, a command following the method definition, which ideally, the environment variable is expected to understand. Now, when this malicious payload with the method definition and the command is passed on and goes to the environment variable, the Bash interpreter, command interpreter, is not expecting anything of this sort, such payload. Hence, it doesn't know what to do, and what to do with the string, that additional string that is coming after the method definition. So the bash program tries to, takes it as a command and tries to execute that command. So that is how the end user or an attacker is able to execute arbitrary commands using this vulnerability and the bash interpreter. Bash shell versions up to 4.3 are vulnerable. This ShellShock vulnerability is expected or stipulated to be one of the nastiest vulnerability discovered till date. It is expected to affect more than 50% of the devices that is connected to internet. These devices could be the server platforms, the network platforms, or even the handheld devices. So now we have the basic understanding of the ShellShock vulnerability, and we are going to look at some of the attack vectors. HTTP remote exploit, HTTP attack vector we'll be discussing in detail. I'll be showing some of the demo also, and later we'll discuss the SSH and DHCP attack vectors. So here, a remote user sitting over the internet tries to access the application vulnerableweb.com and modifies the request and sends this payload, the malicious request, which if you look at the user agent header, this user agent header has been tampered and it contains the malicious payload. Once this request reaches the server, web server, there are certain events that takes place at the vulnerableweb.com server. So there is a process corresponding to vulnerable.cgi, that is the CGI program. We call it as a parent process. As a nature, any parent process or a web server program, whenever it invokes a bash shell or a command interpreted program, it passes on all the header parameters to the child program or the bash program in the form of a variable, environment variable. So request header is passed on to the child program, that is the bash program, as an environment variable. Now, if you look at the bash program, bash interpreter or child process, there's a command written to take the user agent value and see if it contains a keyword like Firefox, and if it is there, then log it in the text file named as log.txt. Now, since this command is reading the value of user agent parameter request header and searching through the value for the fire command, fire text or a string, this command gets modified as shown below. The actual command, because of the malicious request that the user has sent, the actual command will look like environment user agent is equal to method definition, and then followed by a command, which arbitrary command that the attacker wants to execute, which is nothing but to read the content of etc password file, and then followed by the actual command that is supposed to be executed at the bash command prompt. So since the actual command has been modified, the password content file, content of the password file is read, and it sends sent back to the end user by the web server. So this is the overall concept how HTTP remote exploit would work, for exploiting the ShellShock vulnerability. On the next slide, we'll be showing a quick demo of the same exploit. So we have set up a test application which uses CGI in the backend. So first of all, we try to access the CGI URL from the browser. We capture the request in a web proxy editing tool. As of now, we are using Burp Suite for capturing the web request. Here, if you see, the user agent has a standard value, that is Mozilla, since the request was triggered from I, though it's capturing showing it as Mozilla. Now we modify this user agent value with the malicious payload. This payload may seem to be bigger than what we saw on the previous slides because it has a lot of fillers in between, like test and content type. This request is forwarded to the vulnerable server, and then a response is sent back. So if you look at the response, it contains the etc password file details, the contents of etc password file. Now, does it mean that all of our web servers or applications are vulnerable to this attack? The answer is no. This remote exploit will not work if your application is not using any CGI scripts, though you have a bash shell installed on your web server. If there's no CGI program running, if there's no other program, let's say PHP file or JSP pages, if it is not invoking any of the methods like exe, system, or popen for the purpose of executing the commands, then your application is not at risk. Even if your bash shell is invoked, provided that you have certain applications that run certain commands, OS level commands, and passes on that result of bash command to the application back, and then to the end user. If your command does not use any environment variable explicitly or implicitly, then your program will not be at risk, or your application will not be at risk. Now, let's assume that your application is designed to use bash program, and it executes certain bash commands with environment variables. But if this environment variable, value of this environment variable cannot be controlled by the end user, then also your application and web server is not at risk. But at times it becomes very tricky to really figure out what is present on your web server or the application hosted on your web server, whether it uses any CGI program or not, or if it is a PHP or JSP application, is there any dangerous command execution method are we using? Is it like these methods are using some environment variables? So it's a very tricky question to answer, and there's no shortcut to conclude or identify what is really happening at your web server or application server. So the only way is to, if you want to be sure, you will have to conduct certain tests. Now we'll look at the other attack vector, that is SSH. We'll not show you any demo for SSH or DHCP attack vectors, because the objective of this webinar is to help you primarily basically just get a basic understanding of the ShellShock vulnerability, and then go ahead and define a proper mitigation plan that may suit your organization or your need, and then execute that. We'll just help you with some guidelines. We'll give you some mitigation plan that we feel, in a general sense, it should be applicable to most of the organizations. So SSH attack will work only if user is authenticated. Then they can try and exploit this ShellShock vulnerability over SSH. You need to worry only if you are using certain force commands or authorized key commands for restricting user privileges or the commands that an end user can execute. If your SSH daemon or server is configured to use two-factor authentication, then you may have to be concerned, because if your SSHD users, all of your users are already having a root level access, then for them there is no need to authenticate and try this exploit to elevate their privileges. There is no need, so they will not try that attack. So that is the question that we have. Now, why this attack actually works? The basic concept remains the same, means the command that is being executed, if it is using some of the environment variables which can be controlled by the end user, then this exploit will work. So in the case of SSH, certain environment variables like SSH original command or term environment variable is used whenever end user issues a command to the SSH daemon. Then these environment variables are used implicitly by the SSH daemon. And as the name suggests, SSH original command contains the actual command that user has issued. Since user can issue any command, malicious command with the attack payload, as we saw on the previous slide, this vulnerability can be exploited over SSH remotely. So how the attack works in real world is there is a SSH server, a user sitting over the internet. It could be an intranet or internet user. First of all, user tries to log into the server. Server responds with a successful response, it's a login success. Then the user issues a malicious command. For the sake of simplicity, we are using the same set of payload. This payload may vary. There could be a magnitude of other commands that you could run on the server. So once this command reaches at the SSH server, these events take place. If your SSH server is configured to force certain commands to for the end user, means before the end user command is executed, your SSH server can be configured to execute some XYZ number of commands before the actual user command is executed. So these commands you can define in authorized key file. So for the sake of simplicity, we have shown that authorized key file has a command named command1. Then this is the user entered command. You could see the server event, and finally a bash shell is invoked. On the bash shell, the sequence of command should be like this, wherein environment variable SSH original command takes in the value of user entered command. It stores it in SSH original command variable and goes ahead and executes the authorized key file command before it goes and executes the user issued command. You could see in the next step. The step 2, the actual command is executed. Step 1, the authorized key file commands are executed. But as you see, it is taking the user entered value and storing it in SSH original command environment variable. This is actually modifying the first command itself. And since first command is coming in from the authorized key file, it is expected to run with the elevated privileges, and the end user is able to modify the first command, which is running with the elevated privilege. End user command will also eventually run with the elevated privileges. So that is how the SSH attack vector would work for elevating the privilege and executing other arbitrary commands that you are not supposed to execute as an end user. Now we'll look at the DHCP attack vector. One of the key requirements for a successful exploit over DHCP is first of all, you will have to compromise a DHCP server present in your network, or you may have to compromise any server present in your network and configure it so that it starts spoofing the DHCP server IP and poses as a DHCP server in your network. And so once the compromised DHCP server is present, this can infect all the other client machines, machines are present on a network which is running a DHCP client script to communicate with the DHCP server. We'll see on the later slides how exactly other systems can be infected. So let's say there is a client machine present on your network and a DHCP server which is already compromised. Client machine runs a DHCP script, and before, so as soon as the DHCP script is run, client machine communicates with the compromised DHCP server to fetch certain pre-configured parameters along with the IP allocation request. Server responds with a malicious parameter value. For example, option 114 can be used to fetch the update server URL. So this value, instead of giving a URL, DHCP server can respond with the malicious payload that we have seen on the previous slides. So once this parameter is received by the client machine takes these parameter values, stores it in the environment variable, and starts executing the remaining DHCP script commands. So in the process, whatever malicious payload which was sent from the DHCP server also gets executed as a command on the client machine. So this is how the client machine can also be compromised. Now in your network there could be n number of other machines which might be communicating with the compromised DHCP server, and in turn they will also get infected. So that is why we say that DHCP attack vector of ShellShock vulnerability is vulnerable in nature, because it can propagate through your network and infect, and help compromise other systems also for an end attacker. So we have seen till now we have seen the ShellShock vulnerability. We understand what it is. We have seen certain attack vectors like HTTP, SSH, and DHCP. But are there any other attack vectors? So there is no concrete answer to this question. More possibly yes, because any system that is, or any system or program or daemon, that is using or invoking a bash program internally, bash shell internally, and it is using a user environment variable that can be controlled by the end user or the attacker, then your system or your program might be vulnerable to this sort of attack. So the only possible way is to test your system and identify if there's any such program. On the later slides, we'll see how exactly you could figure out whether your end machine or end system is vulnerable to this attack or not. So how does this ShellShock vulnerability affect us? What is the impact? As we know that ShellShock vulnerability can be exploited to run arbitrary command on the targeted machine or compromised system. Since arbitrary commands can be executed, privilege escalations can be done, as we saw in the case of SSH. Multiple files on the end machine can also be accessed. For that sake, any file in the web root can also be accessed and modified, which will result in application defacement, privilege escalation, as we saw in the case of SSH. Authentication bypass is also possible. In case of SSH, we saw two-factor authentication can be bypassed, and we since we saw the example or attack scenario for DHCP, this is vulnerable. If this exploit happens, particularly the DHCP attack vector, it can propagate propagate through your network and result in further system compromise. What does it mean to business? So if this exploit is successful, an end user can steal sensitive, or an attacker can steal sensitive information, which will result in a data loss or information disclosure. They can bring down your system, that will cause a service destruction, financial loss. The time duration for which your business is down, you are losing money, and finally, it could result in reputational damage as well. So now we know the impact. CVSS has given the base score rating of 10 to this vulnerability. So we know the impact is very high, and the magnitude of devices that it is affecting is also quite high. Now, what should we do as an end user, as as a security professional? What can we do to help mitigate these vulnerabilities for our organizations? So since we know that HTTP remote exploit is one of the easiest attack vector and easiest to exploit, and it doesn't need any sort of authentication if your public facing application and public facing pages are using some sort of CGI script or any command execution methods in the backend, this is vulnerable. So our first objective should be, or in phase 1, we should try to identify such servers and applications and prepare an inventory of such servers and applications. Test these systems via automated tools or manually for identifying the affected systems, then fix them on priority. In phase 2, we could look at other services like internet-facing devices, and we can see if vulnerable services like SSH and all are exposed. And if it is there, then we should follow the same steps as discussed in phase 1, because SSH exploit will need some sort of authentication before you could do the actual exploit. That's why we are giving it a lesser priority. So once you patch up your internet-facing system and you're confident that it is secure, in phase 3 you could look at all the remaining hosts and test them for identifying the affected vulnerabilities and patch them as per the vendor advisories. On the later slides, we'll see the detailed steps for identification and mitigation. Now, how to test these systems to identify whether it is affected or not? So there are two ways possible: automated test and manual test. So since we know the most critical attack vector is HTTP, our first objective is to identify those servers. So for that sake, you could run an unauthenticated scan using free or commercial vulnerability scanners that is available in the market. NISTParker Community Edition is free. Anyone can download and scan their web applications to see if it is vulnerable. You could use Nessus scanner. Nessus has come up with certain plugins and a dedicated scan profile called ShellShock detection policy. You could use it for detecting HTTP vulnerability in your application, ShellShock vulnerability in your HTTP application. Then you could use Qualys scanner. For unauthenticated scan, they have a signature called QID 1303. So you need to ensure that this signature is updated in your Qualys box. So first, unauthenticated scan will primarily target the HTTP attack vectors and identify the vulnerabilities that would be exploited over HTTP. For finding the other attack vectors and the vulnerabilities in your system which can be exploited through other attack vectors, you will have to run authenticated scans. So here you could use Nessus again and Qualys. You could key in the system credentials so that these scanners are able to log in and run certain tests to figure out whether your end machine is vulnerable or not. So for Qualys, you authenticated scan, there are different plugins, QID 122693 and QID 122698. You'll have to make sure these plugins and signatures are updated. Now, how to test using NetSparker? So NetSparker Community Edition. So once you install the NetSparker, you can configure the scan policy. You can go to scan policy editor. You can select the command injection group of checks. Under that, you could select the ShellShock vulnerability as shown here. Once the scan is policy is configured, you could run the scan. You could provide the URL. It would be an unauthenticated scan. Community scanner, NetSparker Community Scan Edition does not give you the flexibility to do authenticated scan. So you give the URL of your application and run the scan, and you can see the end result. It is able to identify the HTTP ShellShock vulnerability. You could, in the similar fashion, you could configure and use Nessus. So Nessus, as soon as you log in, you can go to policies. Under policies, there is a predefined policy called ShellShock detection policy. If you click on this policy, it will ask you to key in certain details like what will be the policy name, what sort of web application scan you want to do, whether it is going to be quick, normal, or thorough scan, and then you will have to give the base URL of your applications for the crawling purpose. You configure that, and finally you will have to give the credentials for the Nessus scanner to log into your end machine in order to detect SSH, detect this vulnerability using SSH sessions. Then you could go to the scan section and you could run a quick scan on your target machine, and it will detect the vulnerability as shown here, and you could analyze the vulnerability in detail. Exactly, it may give you the bash version as well. So these were the automated steps for identifying this vulnerability. You could also follow certain manual steps to identify this vulnerability in your system. Log into the host, check the bash package version. Any version that is lesser than 4.3 is vulnerable. So you could run two commands like chsh. This will tell you what is the default shell for the logged in user, and you could also use bash version command to check the version of bash package. For different Linux flavors, Linux or Unix flavors, these commands may vary, so you may have to refer to the user manual. One more thing, since this is a package which is shipped with many other operating system or sub Unix based systems, the versioning of the bash package may vary. They may be using 4.2 or any other package, older package, and the updated package may be 4.3 or 4.2, whatever. So this will not give you a very clear-cut idea if it is a non-Linux system, not Red Hat system. So for other systems, if you want to manually identify whether this vulnerability affects your system or not, you could run this POC command. This is environment variable and then the payload, which is a non-intrusive. It will not cause any sort of damage to your system. It tries to run two commands, echo vulnerable to and echo ShellShock. So if your system is affected, the result will show as vulnerable to ShellShock, means both the commands have executed. If your system is not vulnerable, the end result will be an error. It will the bash interpreter program will throw this error wherein it's not able to understand the method definition provided to the environment variable. So now we know we have a good idea of ShellShock vulnerability, the attack vectors, and we also know, how to identify it. So for a big enterprise organization, identification step could be a challenge, and so there we could come in and we could help you out in the identification phase, and then we will move to the fix section, means how we can fix it. So there are a few generic steps which will be applicable to most of the system. One is if the vendor has provided a patch, you install it. If there is no patch available, probably a package update will work. If even if the package update, few vendors are still working on the patches and updating their packages. So till the time the package patch is released, you could make sure your firewall, IDS, IPS signatures are updated, so that it will detect any attack that might be in progress. Some of the web content filtering devices has not released any patches, or they do not intend to release any signature update as well. So in that case, you could manually add this signature, which will help you identify and block certain attacks exploiting ShellShock. So this is a string which is highlighted with red. You will have to put it in your signature, and all the variants also. You'll have to make sure all the encoded formats of this string, and with additional white spaces in between, it should be added to your web signature or server filters. Another temporary mitigation, is to restrict access to the bash shell from the end user, and also some of the applications, your web applications, if it is using a bash program, then you may have to modify those programs to work on a different interpreter, like corn interpreter and all, and you may want to disable bash shell if not needed. So it's been almost 2 weeks since this vulnerability has been publicized. So if you have not taken certain immediate actions to contain this exploitation of this vulnerability, you may try and look at these steps, fix steps, mitigation steps. That is to update your firewall, IDS, IPS, updating your web content, web filters and webs with the string shown here. You may also want to restrict access to bash shell by the end users and the applications, and if not needed, you may disable the bash shell completely. And finally, if you are disabling the bash shell, and if there is any dependent program that uses bash shell, you may have to modify that program for making it compatible with other bash interpreter. Sorry, other interpreter, command interpreter like corn. So here is a list of affected and unaffected platforms. So most of the Linux and Unix based systems, the operating system platforms are affected, and then they have come up with the fixes as well. Most of the fixes are complete. They will completely mitigate this vulnerability. Initially, Red Hat came up with a fix which was partial, and it was not mitigating the vulnerability completely, but 2 days or 3 days ago, they have released a new patch or updated package, bash package, which will mitigate this vulnerability completely. So all the Red Hat versions like 4, 5, 6, and 7 are affected, and the solution is to update the bash package. They have also suggested some of the workarounds wherein they wanted to enable the mod security module and add certain signatures to mod security for preventing this attack. And they have also suggested to install some of the other packages like LD, proc, and systab, etc., which may help mitigate this vulnerability. So Mac OS, Ubuntu, Debian, AIX, all of them, Solaris, CentOS, Fedora, all of them are vulnerable, and most of the mitigation, they have most of the vendors have released the updated bash packages that you may have to install. We have also collected a lot of advisory links and workaround links from provided by the vendors, which is present here as in a form of hyperlink. So if you want this list of suggested mitigation fix steps, package update steps for all these platforms, you could share it separately. Then there are other set of platforms, FreeBSD, and as we can see here, network platforms like Checkpoint, JuneOS, ScreenOS, and all are also affected. ScreenOS and JuneOS are not affected, but Checkpoint, Cisco iOS are affected. Some of the web proxies like Nginx is also affected. Apart from these, web servers, network devices, some of the load balancer, big F5 big IP, this is also affected. Other than this, Oracle products are also affected. If you look at this Cisco iOS, Cisco multiple products are affected with this vulnerability, but they have not come up with any they have not confirmed any fixed availability, and they wanted the end users to wait for some more time before they release a version upgrade for Cisco iOS and other products. Now, if you look at some of the WAF, IDS, and IPS products, Checkpoint, Imperva, FortiGuard, and SonicWall has come up with a signature update. So if you have the signatures updated, it will detect any attack that is trying to exploit the ShellShock vulnerability. Big IP ASM, which is a WAF, has not come up with any signature update, and they have recommended their users to update the signature manually. And they have also suggested some workaround to restrict access to the product management interfaces and all. So that is all about ShellShock vulnerability and the affected platforms. Some of these WAF, IDS, and IPS products are affected itself, means they are also susceptible to ShellShock vulnerability. So apart from providing the signature updates for protecting the end systems, they can also be be a target. So for that also, some of the vendors, like if you could see Checkpoint has released a hot fix also, which will help mitigate the vulnerability in Checkpoint products, and then they have released the signature updates as well, which will help protect the end systems. So now we'll move to the question session. You could ask the questions that you may have. Any questions? Okay, so one question is to see if there's any nmap command to which can help us identify this vulnerability. So as such, till yesterday, based on whatever readings I did, I couldn't see any nmap command. Nmap may come up with some NSCA scripts as they did for detecting the Heartbleed vulnerability, but as of now, there's no NSCA script as such. So we may have to wait. Okay, the next question is, does routers and switches internal to network to be patched or secure the perimeter by applying fix on IPS? Yeah, it's again, looking at the different attack surface. If your internal routers and switches are not exposed to the internet anyways, So updating the signature on perimeter routers will prevent the end systems which is exposed to the internet. But internally, if you look at the internal router and switches, it is advisable to update the router and switches as well. It may be a long-term objective, and as an immediate solution, you could update if you have an internal IPS or IDS, you could update the signature there, so that any internal exploit that someone authorized user from the internal network tries to exploit this will fail. But in the longer run, it is advised to update your router and apply the fix and patches. Okay, as I said, this is an arbitrary command execution. So for the sake of simplicity, of the payload, so that you could understand how the attack works, we tried to fetch only the etc password file. But you could run any sort of command on the end machine. And try to access other files. You could even try to shut down the system, or you could try and install some of the other viruses on your system. You could fetch the installer from the internet. You could use wget and you could run a netcat, so to provide a reverse shell and all those things. So there's a magnitude of attack that you could do targeted to your system, but there's a restriction. So I'll take an example of the HTTP attack. In the HTTP attack, okay, sorry, before I go to the answer, I forgot to explain the question which was asked by one of the audiences. The question was, will the altered payload fetch only etc password file or anything else? Is there any change in the configuration files? So I'm trying to answer this question. So as arbitrary command execution is possible, for the purpose of simplicity and showing the demo, we only fetch the etc password content, but any other system files could also be accessed, and it could be modified or tampered as well. This will depend on the privileges of the end process that you have compromised. Now I'll take an example. I'll explain it with the help of an example. So in case of HTTP exploit, if you see, there is a web server hosted on your end machine. This web server might be using an account, let's say a web server account, for granting permission to the web server processes. So this account that you have created for the web server process, it may be a low privilege account, or you might be using a root level account for your web server account. You may have granted that permission. So depending on what level of permission your web server account has, the end user can execute the restricted commands, or they can execute root level commands as well. So as a security practice, it is well known that any of the web servers that you host, that you install on your own end machine, you need to assign the restricted privileges to the account which is operating the web server. So if that is the case, then only restricted commands can be executed. The end user may not be able to access etc password file or shadow file or any of the other configuration file, but they may certainly be able to access the web root file, and they may be able to modify it as well. So if they modify the files present in the web root, any HTML file and all, that will result in the defacement of the website. Any other questions? Okay, next question is, what about McAfee IDS? Does it protect from ShellShock? So yesterday I was going through the McAfee website, and it seems they have come up with a signature which should protect against ShellShock vulnerability. Based on my research, I came to know that most of the security devices, WAF, IDS, and IPS, they have come up with a signature to identify this ShellShock exploit. So most likely McAfee will also have it. So I'm not very certain about it, but I had a quick reading yesterday, and I think McAfee has the signature. Okay, next question is, do we need to restart after applying the patch in Red Hat? In Red Hat, if you see certain patches they have given, so that needs a restart. They have given some workarounds also. As I said, two other SecTap and other packages they wanted you to install. So if you install those packages, they have recommended for a restart. For other packages, just a bash upgrade, you may not need a restart. The next question is, do we have any exploit and payload in Metasploit? Okay, so this honestly I'm not aware of it. I have not used Metasploit for any of these demos that I have worked on, because you may not really need a Metasploit to exploit these vulnerabilities. These vulnerabilities are very straightforward. If you look at the HTTP attack vector, it's just a matter of putting a payload, which is a very standard payload. You could get it readily available on the internet and try to exploit this vulnerability. So as such, no, I am not aware of any payload which is present in Metasploit. Is there any more questions? Okay, question number 7. Nowadays, we are getting to know lots of vulnerability like ShellShock, and earlier it was Heartbleed. So is it suggested to not use freeware like Linux system? Okay. Okay, so answer is, it lies in the concept of using the open source tools. It's good that we come to know about these vulnerabilities. If it is independent of whether it is a freeware or if it is a commercial product, vulnerability could be present in any product. It's just a matter of identification and publicizing it, and once it is publicized, your end systems can be targeted, be it a commercial system or a freeware system. This having a freeware or open source system gives you one edge over the non-commercial over the commercial system is since it is a open source, it's a freeware, it's widely used. Linux systems and all, it's used very widely, and and since and once the vulnerability is identified, you can patch it. But what about the systems which is not very popular or which is commercial and people are not using it widely, but there is a vulnerability present? So these vulnerabilities, if for that sake, if you talk about this ShellShock vulnerability, it was present. It was present since the creation of Bash shell itself. 25 years ago, and many people might have exploited it, and no one knows about it. So the similar thing could be applicable for a commercial product also. And due to the fact that commercial products are not that widely spread, and it's very likely that those vulnerabilities will never be detected or publicized. But someone who knows, who has found this vulnerability, some expert or a malicious user, they might be exploiting it in the backend, and no one knows about it. So I would not, I don't think it's a matter of open source or freeware software stopping. If we stop using this freeware software, I don't think it's going to help the cause. Next question is, we patched in bash vulnerability on IPS and WAF, Is it necessary to fix the same on the web server as well? Okay, so first of all, whoever has asked this question, I am not sure when you say we patched in bash vulnerability in IPS and WAF. So as I said, IPS and WAF devices or components are itself susceptible to this attack. Means this attack this vulnerability is inherent to the IDS and IPS devices also. For the example, I'll take a checkpoint firewall, which is susceptible to ShellShock vulnerability, and it can be exploited to compromise the checkpoint device itself. So this is one thing. And then Checkpoint has also released a patch which will update your signature database. So once the signature database is updated, it will try and identify the attack pattern and it will block it. Okay, so there are two ways to look at it. One is the hot fix, which will mitigate the vulnerability which is inherent to your security devices, IPS or WAF, and another is the patch update, which will prevent your end system. So we need to see this, what exactly you have done. If you have just updated the signature on the IPS device, then it will certainly prevent your web servers, which is sitting behind your IPS and IDS. But since there's always a chance of coming up with a new attack vector or new payload, which may bypass your IPS or WAF filters or signature pattern and go and hit your web server. So it's advisable to update your web servers also, because web servers are again one of the easiest attack vectors. Using HTTP, it can be targeted. So, and it's most susceptible to ShellShock exploit. So we suggest that you patch the web servers as well. Next question is, how can I capture packets from Linux machines? Any tool available? Okay. See, there are many network sniffers available. You could capture all those network level packets using the network sniffers like Ethereal. ShellShock also has the Linux version of it, I believe. So you could use those packet sniffers to capture the network level packet. The only problem you will face is if it is a HTTPS packet that you are sniffing over the network, you may not be able to see the content of HTTPS packet as it is encrypted. So other way is, if you could if it is a HTTP application, then definitely you could look at all those traffics as well. Means non-encrypted traffic you could see using the packet sniffers. So you could install Ethereal and try. Next question is, mobile OS like Android, Apple, iOS, BlackBerry are affected. If yes, any remedy for the same? Yeah, based on the research I've done, I've come across some of the posts that claims that Android and the mobile OSs are also affected, and the remedy to fix those vulnerabilities for Android or mobile, Apple, iOS would be, I think some of the vendors have released the updated bash packages for your Android devices also, and the next is you may have to look at upgrading it to the new version of the OS. So to be honest, I'm not really sure of what all the exact specific patch releases and all for Android and Apple. I've not looked into it. Any more questions? For further questions, you could write to me, or even for getting the consolidated list of affected, non-affected platforms and advisory links, we could share it, or I could share it over an email. Okay, so thank you everyone for joining, and and asking some of the good questions, and I hope I was able to answer most of your questions and you have certain takeaways from this session. Okay. Thank you everyone. Have a nice day.